Let's continue our math adventure. Today we are going to learn how to multiply fractions. Now, multiplying fractions is much different than adding and subtracting fractions. So let's take a model, look at a model and see how it actually is working. If I have 5/6 times 1/2, the way that the model works is we're going to draw a big rectangle. And we're going to place 5/6 on one side and we're going to put 1/2 on the top. The 6 tells me that I need to divide that rectangle into 6 equal pieces. And I'm going to do it from left to right because that's where I have my 5/6. So if I go and I cut it into 6 equal pieces, it should look like this. Now, the numerator tells me that I'm going to look at 5 out of those 6 equal pieces. So I'm going to color in 5 of those. And I just modeled 5/6. Now I still have to model 1/2, and 1/2 is sitting on top. So I'm going to model that from top to bottom. So I look at that denominator, and that denominator says I need to split it into 2 pieces from top to bottom. So I'm just going to cut it right there. Now those are equal sized pieces, and I only want to look at 1 out of those 2 pieces. So I'm going to color here. Now my answer reflects what is colored by both the black and the blue. So when I take a look at this, let's take a look at our denominator, which is our total number of squares. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 total equal sized squares, and those that are colored by both the black and the blue are 1, 2, 3, 4, 5. Therefore, 5/6 times 1/2 is 5/12. Well, when we take a look at that, we start to see a pattern come out. And I can see that if I take my numerator of 5 times my numerator of 1, that equals my answer of 5 in my final answer. If I take 6 in my denominator times 2 in my denominator, it equals 12. So that leads me to how you multiply fractions. It's always numerator times numerator and denominator times denominator. And we don't ever have to find common denominators. That's why kids like multiplying fractions far more than they like adding and subtracting fractions. The reason why is because from the model we see that naturally we get same size pieces. So we don't need to worry about it with multiplication. So all I have to do is take a look at my problem, and I do 3 times 5, which is 15, and I do 4 times 8, which is 32. Now I always think to myself, can I reduce that final answer? If I can, I have to. If I can't, I just leave it. Same rules apply if we have variables and exponents. So we have to go back and remember, if the bases are the same with the variable, all we need to do is add the exponents. So I'm still going to do c times 4c, but that 4 stays by itself, and I'm going to do c to the 2 plus 4. Now remember, I only wrote c there. I needed to have that square there, and I only wrote c there, and I needed to have that 4 there. That's how I got those exponents. Now the bottom still remains the same, 7 times 5, so that becomes 35, and when I put it all together, I get 4c to the 6th power over 35. Little more complicated, we have to pull on our background knowledge with our exponents, but it always works the same because that's how the exponents work. Now, I do a trick because I don't like to always have to remember to reduce in my final answer. So I always reduce on my diagonals before I actually even multiply. And this is just a trick of math that always works. So I go and I take a look at my diagonals. And I look at those numbers and I think to myself, is there anything I could divide both of those by? Now notice, this is a positive and that's a negative. It doesn't matter. I don't have to remember that because I always know that a positive times a negative is a negative. So I can just place my negative in my answer. But I know that I could actually divide both of these numbers by 5. And 10 divided by 5 is 2. 5 divided by 5 is 1. And I just changed and reduced those fractions. Now I can also do it on this side. And I always look only on the diagonal. And I know I could divide this by 3 and this by 3. And I get 4 here and I get 1 there. Well, now those are my new numerators. So it's 1 times 1 over 2 times 4. So I get a negative 1. 2 times 4 is 8. And that would be my answer. So I always reduce on the diagonals. Now, I would also do that if I have variables. So I take a look at this diagonal. I see there's a negative and a positive, so I know my answer is going to be a negative. But I know I could divide by 3 on both of these, and I get 4 and 1. Now, I can't do anything here because I don't know what m is. So I'm just going to leave it. So this becomes m times 4 over 1 times 5. So I get m times 4 is 4m. 1 times 5 is 5. That would become my final answer. Now the last kind of problem you're going to have mixed numbers. And mixed numbers work differently than they do with addition and subtraction. So in order to multiply fractions, we have to have a single numerator and a single denominator. But I know that I can change any mixed number to an improper fraction. And if I do that, I have my single numerator and my single denominator. So remember, you're going to take the whole number and multiply it by the denominator. So 2 times 3 is 6. Then I'm going to add that numerator. So 6 plus 2 is 8. And that becomes 8/3. Now, I keep that multiplication sign. The next one's a negative. It doesn't change, so I have to keep that negative there. 3 times 2 is 6. 6 plus 1 is 7. I see 7/2. So now I look on these diagonals. Notice here, I can't do anything on this diagonal, but I definitely could do something on this diagonal to reduce it. So I'm going to divide by 2 and divide by 2. Nothing there, and I know it's a positive times a negative. My answer is negative, and I just place it. That becomes 4 times 7 over 3 times 1. 4 times 7 is 28. 3 times 1 is 3. Now, if I started with mixed numbers, I usually end with mixed numbers. So this is an improper fraction. The numerator is bigger than the denominator. I have to change it back. So that negative still follows it, but this is just a division problem. And I know that 3 times 8 is 24, 3 times 9 is 27. So it goes in 9 times with 1 left. That becomes my new numerator over my original denominator. My answer would be 9 1/3. So always when you're multiplying mixed numbers, change those mixed numbers to improper fractions, but realize you're going to have to change them back at the end. That is how we multiply fractions. I hope you are enjoying this lesson, and I hope you're ready to take on the challenge. Let's get to work, and let's do the best we can.